In 1966, biological trials were carried out on the south coast of England. They were designed to measure the properties of bacterial particles in an aerosol at various distances downwind of a line release. The basic aims were to assess the risk to this country of biological warfare and to devise a satisfactory method of detecting biological agents in the atmosphere. Answers were sought to the following questions. What is the concentration of particles? What is the dose of bacteria? Do the bacteria survive? Is survival dependent upon particle size? Can the bacteria be detected? Lyme Bay and the surrounding countryside were chosen for the trials because the area is close to Portland Naval Base, and onshore winds can be obtained with any wind direction from 100 degrees through south to 300 degrees. A suitable control site was found at Fleet, which is only 6 miles from the naval base and 60 miles from Portland. The method of conducting the trials was for a small ship to lay a crosswind line source of bacteria in the path of an onshore wind. As the cloud drifted inland and over the surrounding countryside, it was sampled by mobile sampling stations. The line source was between 5 and 20 miles long, and it was sampled at distances of up to 40 miles downwind. The trials were controlled by radio from the control site, and, if necessary, through a radio relay station suitably positioned on a high hill. At the end of the trials, the samples were brought back to the mobile laboratory at the control site for assessment. On the first day of a trial period, which was usually 7 days, the 2 mobile laboratories left Portland and travelled via Blandford and Dorchester to Weymouth. There they left the main road and soon arrived at the site. First, the assessment laboratory, known as the night ferry, was backed into position and jacked up. Then, the control laboratory, the Golden Arrow, was parked. They were then both connected to the power supplies and other services. Instruments and aerials were then installed on the roof of the Golden Arrow. First, an anemometer and wind vane were assembled. Then an aerial was erected for the VHF radio telephone used for talking to the ship and to the mobile sampling stations. The UHF aerial for communicating with an aircraft used to collect meteorological data was connected. This was followed by an HF aerial used for communications with Portland and for receiving meteorological data. And then an optical rangefinder used for tracking zero-lift balloons was erected. The telephone was connected and communications were established with base. Finally, the 3 centimeter and 10 centimeter radars were connected to the display units in the Golden Arrow. Ancillary apparatus and stores arrived in a 3-ton lorry. Fuel oil for the generators was unloaded, together with a meteorological screen, among many other items. Protection for the site was provided by a dog managed by 2 patrolmen who brought their own caravan and who maintained a 24-hour watch. By now it was time to retire to the nearby Moonfleet Hotel for a well-earned lunch. After lunch, more of the crew arrived at the site, ready to continue the preparations. One of the most important jobs was to prepare the mobile sampling stations, which had already arrived. These long wheelbase Land Rovers have been specially modified for the role of sampling stations. An engine-driven pump had been mounted under the chassis, and this was connected to a vacuum manifold on the rear of the vehicle. The manifold rotated about a vertical axis so that the sampling devices could be made to face into wind. 4 sampling devices were used in these trials. The cascade impactor was used to obtain an estimate of the number of biological particles in the air. The 3-stage sampler was used to measure the dose and the viability of the test organism in the cloud. The slit sampler was used to establish the time of arrival and duration of the cloud at each station. The cyclone sampler was used to collect concentrated samples of the cloud for detection purposes. In the slit sampler, particle-laden air is drawn through a radial slit. The particles in the air are impacted onto nutrient agar contained in a petri dish. The dish is rotated in steps so that 60 separate samples of the cloud can be collected on a single plate. Rotation is controlled by an electronic timer, which enables the duration of the sample to be selected and indicates the number of the sample being collected. The petri dishes for the slit sampler were labelled with a coloured number, and the starting position was carefully marked on the underside of each one. The dishes were then packed into a transport box. Finally, the timing circuits of the control box were adjusted. The 3-stage impinger fractionates the cloud into 3 size ranges in a manner suitable for biological assessment. This sampler collects particle-laden air at 55 litres per minute. The particles larger than 6 microns in diameter are collected by impaction on the moist surface of a sintered glass disc in the top stage. The finer material passes into the second stage, where particles between 3 and 6 microns in diameter are impacted onto a second sintered glass disc. The remaining particles are removed in the third stage, which is a swirling impinger. In use, the sampler was supported on a holder, which permitted the device to be levelled and which provided a baffle to increase the efficiency of collection for large particles. Normally, each 3-stage sampler was operated for half an hour. The top stages of the samplers were filled with collecting fluid so that the disc was just wetted, and a fixed amount was put into the bottom stage. They were then packed into carrying boxes, and after this, dilution tubes were prepared ready for the assessment later that day or on the following day. The cyclone sampler collects air at 75 litres per minute. Air enters and travels in a spiral path, throwing the particles to the wall. At the bottom of the cyclone, the direction of flow is reversed, and the air leaves in a spiral path. Collecting fluid is injected into the intake at a rate of 1 milliliter per minute. This liquid washes the internal walls and carries the particles derived from the cloud into a bijou bottle at the base of the cyclone. In field use, the bottle was changed every 5 minutes. The sample bottles were carried in a special box, which also contained collecting fluid and spare parts. In the cascade impactor, particles from the air are impacted onto microscope slides. These were coated with a sticky surface and then inserted into the impactor. The 3-stage samplers and the plates for the slit sampler, already packed in a transport box, and the collecting fluid for the cyclones were then stored in a refrigerator until required. The other sampling devices were stored on the back door of the Land Rovers, which would later carry them to the sampling sites. Whilst the samplers were being prepared, radio telephones were installed in each of the Land Rovers and checked. Normally, 6 Land Rovers were used, of which 5 were equipped as sampling stations. The 6th has a pneumatic telescopic mast fitted, so that the VHF aerial can be placed 30 feet above the ground. It also has a more powerful radio telephone, in addition to one similar to those in the 5 sampling vehicles. This Land Rover was used as a mobile radio relay station, so that the more distant sampling stations could be controlled. The flow rate of each of the sampling devices is controlled by a critical orifice. The flow rate of each of the orifices was measured and recorded. And finally, the small items of equipment were checked. All of these preparations were made as soon as possible after the Land Rovers had arrived. Whilst this was going on, meteorological information was being gathered in the Golden Arrow. A detailed synoptic chart was drawn from coded data received by radio teleprinter. This was augmented by observations made on the site and by facsimile charts received by radio mufax equipment. Conventional pilot balloons were released regularly and tracked by theodolite. Information from these was used to calculate the wind speed and direction in the upper air. Smaller balloons were filled with hydrogen, balanced to zero lift and released. At night, small lights were attached to them. Each flight was timed and tracked by an optical rangefinder to give the mean surface wind speed and direction. Information on the temperature structure of the atmosphere was obtained from a temperature sonde carried below a small kite balloon. Hydrogen for the balloon was carried to the site, the balloon emptied out of its bag and slowly inflated. When it was safely attached to the winch, the sonde and warning lights were fixed to the cable and the balloon was flown. At night, warning lights were placed in position on the ground. All this time, other preparations had been going on elsewhere. The slurry of Escherichia coli to be used had been produced in the pilot plant weeks before it was needed, so that it could undergo rigorous toxicity tests. It was then mixed with spores of Bacillus glabigii and put into barrels. On the day of the trial, the barrels arrived at Portland Naval Base, and they were unloaded on the jetty alongside the ship Ice Whale. Ice Whale is an experimental trial vessel operated by the Queen's Harbour Master for the Admiralty Underwater Weapons Establishment, Portland. She was suitably modified for biological trials and placed at our disposal for the whole trial period. The ship's trial party went through a changing hut on the jetty so that contamination would not be brought back to the laboratories. The barrels were transferred to the ship and stowed on the upper deck. The spray heads were mounted on a manifold attached to the rear of the ship. The manifold was connected by hoses to a panel from which the sprays could be controlled. With prospects of an onshore wind, the ship slipped. In the laboratory space below, the trial party prepared the sampling equipment designed to collect a sample of the cloud a short distance from the spray. A float was prepared to carry a short-range sampler. divers' torches were attached so that the float could be seen at night. The ship then made for a point upwind of the control site. As the working position was neared, the float was launched. Background samples of the air at sea were taken for comparison with those inland. The spray crew struggled into their protective clothing and went aft to measure and to stir the contents of the barrels, which were then connected by hoses to the control panel. Air was gently bubbled through the suspension to prevent it from settling. This done, the control panel and the sprays were prepared. Meanwhile, down in a large laboratory, helium-filled balloons carrying a radar reflector were balanced to zero lift. A small fuse was placed between the balloon and the reflector, so that after 30 minutes flight, the reflector was released. These assemblies were carried up the gangway and released. As the balloon came away from the ship, it was tracked by a 10-centimeter radar on shore, and this information was plotted in the golden arrow to yield the speed and direction of the wind over the sea. All this time, a 3-centimeter radar was used to observe the position and course of other shipping in Lyme Bay and to look for rain which could interfere with the trial. A final synoptic chart was drawn, and on the basis of all the information available, a preliminary decision was made as to where the ship should start spraying and what its course should be. The siting of the inland sampling stations was also decided. This information was radioed to the ship.
Seven 9, message, over.
7-9, you're okay, send your message, over.
7-9, your alpha will be red echo 00, purple golf 50, over.
7-9, Wilco, out.
1. What is the concentration?
The sampling operators were then given a final briefing, after which they collected the sampling equipment, packed it into the Land Rovers, and left for their sampling sites. Whilst the Land Rovers were on the way to the sampling sites, more balloons were flown to measure the wind speed and direction, and, if necessary, the sampling teams of the ship were given revised positions.
7-2, move to grid reference 621830, over.
Once in position, the sampling operator mounted the sampling equipment on the manifold and made all the necessary preparations. By this time, the ship had arrived at its starting position, and with all meteorological conditions satisfactory, the trial proceeded. The ventilators of the ship were covered. The compressor which supplies air for the sprays was started, and the order was given for the sprays to be turned on. Once the sprays were working satisfactorily, the ship made an S-turn to cause the short-range sampler to pass through the aerosol, and the vacuum pumps were turned on to collect a sample of the cloud only 200 feet behind the spray. The subsequent assessment of this sample was used to show that no damage had occurred to the E. coli in the spraying process. The ship then turned on course, and a careful watch was kept of the ship's progress along the proposed track by means of the Decker navigator in the ship. During the spray run, samples of the suspension were taken for subsequent analysis. Measurements were taken of the air temperature, the wet bulb depression, the wind speed, and the water temperature, and all of these were recorded. Whilst the spraying continued, more zero-lift balloons were released from the ship. These were tracked as they came inland, and their progress was used to estimate the time at which the cloud would arrive at each of the sampling stations. Just before each of these times, instructions were given to the operators for sampling to start. The operator then changed each of the samplers according to a pre-arranged schedule. At the completion of the schedule, the equipment was packed, and the exposed samplers were returned to the night ferry for assessment. The 3 stage samplers were removed from their transport boxes. By means of a pipette, the sintered discs were washed several times with the collecting fluid. The volume was measured, and the fluid was transferred into sample bottles. Some of this was set aside for subsequent analysis by the labelled antibody method. Aliquots of the remainder were diluted, plated out, and the plates later transferred to the hot room for incubation along with the Petri dishes exposed in the slit samplers. The cyclone samples and the slides from the Cascade impactor were put into boxes and returned to MRE for analysis. By this time, the ship had completed spraying and recovered the float. The sampler from this was removed and carried below. Later, the sprays were covered. As soon as the ship arrived alongside the jetty, the samples were taken to the night ferry for immediate assessment. With the dawn not far away, the generators were refueled, and as the balloon flew over the site, activity ceased until later that day. As soon as the bacteria had grown into visible colonies, the Petri dishes were removed from the hot room, and the number of colonies of E. coli and of BG on each plate was counted. These numbers were logged, and from them, the dose and the viability of E. coli in each size fraction of the cloud at each of the sampling stations was calculated. From the meteorological data and from the slit sampler, it was possible to deduce the time for which each sample of the cloud had been airborne, and thus to produce a graph showing the viability of E. coli as a function of duration of airborne travel. First for particles greater than 6 microns in diameter, then for particles between 3 and 6 microns in diameter, and finally for particles less than 3 microns in diameter. This graph shows very clearly that the organisms contained in large particles survive much better than those in small ones. Representative colonies of E. coli were picked off, cultured, and later examined by the use of antisera to confirm the identity of the material collected. Each trace on the plates removed from the slit sampler was marked, numbered, and subsequently the number of colonies in each of the traces was counted with the aid of a microscope. From a record of these, it was possible to construct a histogram showing the concentration of airborne particles per litre of air as a function of the passage time at each of the sampling sites. Later, in MRE, the cyclone samples were treated with labelled antibody in an attempt to detect the cloud. First, a measured volume was removed from the sample bottle. To this was added a measured volume of purified antibody, specific for E. coli. This antibody had previously been labelled with iodine 125. The reaction was allowed to proceed for 20 minutes. A vacuum pump connected to a manifold carrying several filter jigs was turned on. A membrane filter was placed in one of the jigs, vacuum was applied, and the filter was washed with a large volume of particle-free buffer. The reaction mixture was then filtered, and the now radioactive bacteria in the sample were left on the surface of the filter membrane. The filter was washed at least 10 times with buffer to remove all the radioactivity not attached to the bacteria. It was allowed to dry on the jig. The filter was removed, and a well-defined area in its center was punched out and collected in a vial, which was then closed. The vial was carried into another laboratory, where it was inserted into the well of a scintillation counter. The number of disintegrations recorded was proportional to the concentration of E. coli in the sample. These results have been of great value in the process of evolving a means of detecting bacteria in the atmosphere. Also in MRE, the cascade impactor slides were removed from the storage box, stained, washed, dried, and mounted for microscopic assessment in an attempt to determine the concentration of biological particles in the atmosphere. By these combined methods, it was possible to build up a picture of the results of the trial in the following way. At the nearest sampling station, the concentration of airborne particles, as represented by the histogram, was high, and the cloud lasted for 15 minutes. At the second station, the concentration was lower, and the cloud lasted for 35 minutes. At the third station, the concentration was lower still, and the cloud took 50 minutes to pass. At the fourth, 55 minutes, and at the fifth, 90 minutes. The cloud decreased in concentration and persisted for a much longer time as the distance downwind increased. The total dose received by a person breathing at 10 liters of air per minute at the first station was 16,300 organisms, decreasing to 5,800 at the second station, 3,700 at the third, 2,100 at the fourth, and 2,300 at the fifth, the dose decreasing with distance downwind, but becoming constant at the more distant stations. Of particular interest is the viability of the organisms contained in particles capable of penetrating into the trachea and lung, that is, those organisms in particles less than 6 microns in size. At the first station, the viability of organisms in particles less than 6 microns in diameter was 89%. At the second, 96%. At the third, 74%. At the fourth, 59%. And at the fifth, 22%. Whilst these trials were designed for specific research purposes, they demonstrated in a striking way the feasibility of small-scale biological warfare. An appreciable dose of viable bacteria was achieved over an area greater than 1,000 square miles by the release of only 120 gallons of suspension.